In this lecture, I am going to give introduction about regular expression. The language recognized by finite automata are regular language, and these language are described by simple expression called regular expression. Important application of regular expression is text search application or compiler components. Regular expressions are closely related to non-deterministic finite automata. Also, it is user-friendly. In Unix, grep command uses regular expression like notation for describing patterns that the user wants to find in a file. In lexical analyzer generators such as lex and flex uses regular expression. Precedence of regular expression operators. The star operator is of highest precedence. Next in precedence comes concatenation or dot operator. Finally, all unions are grouped with their operands. I am going to give some examples of regular expression and regular languages corresponding to them. Suppose my regular expression is a plus b the whole square. The language will be AA, AB, BA and BB. Suppose my regular expression is a power star. Then the language will be all the combination of a including null value. A square, a cube and so on. So including null value. Suppose my regular expression is a power plus. Language will be all the combination of a, that is a square, a cube, a power 4 and so on, excluding null value. Suppose phi is an regular expression which denotes empty set. Suppose epsilon is regular expression and it is null string. Suppose I have two regular expression R1 and R2, then its concatenation R1, R2 is also regular expression. Suppose R1 and R2 are two regular expression, then union of these R1 plus R2 is also regular expression. Suppose if R is a regular expression, then clean closure of R is denoted by R power star is also regular expression. Suppose I have a regular expression R1 and R2, that is R1 plus R2. Plus sign is used to describe the language having string of either component. R1 plus R2 is read as either R1 or R2. This is the introduction about regular expression.